31st question. The Fourier transform of a double-sided exponential function e to the power of minus a mod t is a 2a by a square plus omega square, b 1 by a square plus omega square, c 2 by a square plus omega square, d a by a plus j omega. The answer is A. We have done this earlier. It is 2a by a square plus omega square. So the answer is A. 32nd question is as follows. A shift to omega naught in the frequency domain for a function is equivalent to multiplication of the function x of t by A e to the power of j omega naught t, b e to the power of minus j omega naught t, c omega naught by 2 pi, and d 2 pi. Okay, this is the frequency shifting property which we have to use. We are actually asking a question in frequency shifting property. The answer is A, that is e to the power of j omega naught t. Let us look at a 33rd question. The Fourier transform of the gate function of amplitude A and a duration minus tau by 2 to tau by 2 is given by A tau by 2 sinc omega tau, b a tau sinc omega tau, c a tau sinc omega tau by 2, and d none of these. The answer is C, that is a tau sinc omega tau by t. It means a rectangular function in the time domain. Fourier transform will be a sinc function, that is a tau sinc omega tau by 2. The answer is C. 34th question is the integral minus infinity to plus infinity e to the power of j omega t dt is equal to A u of omega, b r of omega, c delta of omega, and d delta of minus omega. That means when I integrate e to the power of j omega t dt within limits minus into plus infinity, is it a unit step function in the frequency domain, or is it a ramp function in frequency domain, or is it a delta function in the frequency domain, or a delta of minus omega? The answer is C, that is you will get a delta function in the frequency domain. Okay, the answer is C. Next question. The signum function is defined as A. Signum of t is equal to 1 when t is greater than 0, minus 1 when t is less than 0, or B. Signum of t is equal to 0 when t is greater than 0, or minus 1 when t is less than 0, C. Signum of t is equal to minus 1 when t is greater than 0 and 1 when t is less than 0. D, of course, it's talking about a signum function of f, which is 1 for t greater than 0 and 0 for t less than 0. The answer is A. The signum function is 1 for t greater than 0 and minus 1 for t less than 0. So the answer is A. As you are all aware, the signum function exists like this. It is 1 for t greater than 0 and minus 1 for t less than 0. So this you should take into cognizance. This is a signum function. 36th question. The signum function in terms of unit step function A, u of t plus 1, b 2 u of t minus 1, c 1 minus u of t, d u of t minus 1. The answer is B, that is 2 u of t minus 1. So the answer is B. The next question is 37th question. The Fourier transform of a signum function is given by A 1 by j omega, b delta of omega, c 2 by j omega, d 2j omega. So what is the Fourier transform of a signum function? The choices are given. A is 1 by j omega, b is delta of omega, c 2 by j omega, d is 2j omega. The answer is C, that is 2 by j omega. 30th question. If f of omega is a Fourier transform of f of t, the Fourier transform of f of t multiplied by exponential e to the power of j omega naught t is A. F of omega minus omega naught, b. F of omega naught minus omega, c. F of omega naught, d. F of omega. Again, if you see here, this question is again based on frequency shifting property, which was asked in another way. So the answer is A, that is f of omega minus omega naught. Next question. If f of omega is the Fourier transform of f of t, then the Fourier transform of f of t cos omega naught t is A, half f of omega plus omega naught minus f of omega minus omega naught, B, j by 2 f of omega plus omega naught minus f of omega minus omega naught, C, half f of omega plus omega naught plus f of omega minus omega naught, D, f of omega plus omega naught plus f of omega minus omega naught. So this answer has to depend on the earlier knowledge of us, where we have found out the cos 2 pi f c t consists of two delta functions which exist at f is equal to plus or minus fc. Now this cos function is being multiplied by a function f of t. So the answer is C, that is half of f of omega plus omega naught plus f of omega minus omega naught. Let us see the 40th question. If f of omega is the Fourier transform of f of t, then the Fourier transform of f of t minus t naught is A, f of omega e to the power of j omega naught t, B, f of omega e to the power of minus j omega naught t, C, f of omega e to the power of minus j omega t, D, f of omega e to the power of j omega t. The answer is B, f of omega is equal to e to the power of minus j omega naught t. So this is a time shifting property which we have used. So the answer is B. Next question, question number 41. Triangular function t by tau is equal to 0 for t less than tau. The first option 1 minus t by tau t less than tau, that is mod t by tau must be read as for value t less than tau. B, triangular function of t by tau is equal to mod t by tau for t greater than tau. Third choice C, triangle of t by tau is equal to 0 for t greater than tau and minus 1 for t less than tau. The answer is A, that is the triangular function t by tau is 0 for t less than tau and 1 minus mod t by tau for t greater than tau. So that is the answer A. The next question. The Fourier transform of a triangular function is A, tau sin square f tau, B, tau sinc f tau, C, 1 by j omega, D, j omega. The answer is tau sin square f tau. The answer is tau sin square f tau. The next question, that is 43rd question. The sinc function is defined as A, x of t is equal to sin pi x by pi x, B, x of t is equal to sin x by pi x, C, x of t is equal to sin pi x by x, and D, x of t is equal to sin pi x by pi. The answer is A, that is sinc function is defined as sin pi x by pi x. Answer is A. Let us look at the next question. The next question is 44th question. What is the value of sinc 0, sinc function at 0? A, is it 0? B, is it equal to infinity? C, is it equal to 1? Or D, is it equal to pi? The answer is the sinc function at 0 will be equal to 1, that is answer C. The 45th question is as follows. The sinc x is equal to 0 for all even values of x, B, for all odd values of x, C, for all integer values of x, and D, none of the above. And the answer is C, for all integer values of x, the sinc function x is equal to 0. So the answer is C. The 46th question. The Fourier transform of the function f of t is equal to a sinc 2wt is A pi of f by 2w, B, a by 2w pi of f by 2w minus pi of minus of f by 2w, C, a by 2w pi of f by 2w, D, a by 2w. This question is we have to apply duality theorem and also time scaling if needed. So the answer is C, that is a by 2w pi of f by 2w. The next question is, the Gaussian pulse is given by A, x of t is equal to a e to the power of minus pi of t by tau square, B, x of tau is equal to a e to the power of minus pi t by tau, C, x of t is equal to a pi of t by tau, D, x of t is equal to a to the power of minus at. The answer is x of t is equal to a e to the power of minus pi of tau by tau square. So this is the Gaussian pulse, the famous equation which we should remember. The answer is A. 48th question. The Fourier transform of a Gaussian pulse e to the power of minus pi t square is A, e to the power of minus pi f square, B, e to the power of minus pi f, C, 0, D, e to the power of minus 2 pi f. Here we should remember one important point. The Fourier transform of a Gaussian pulse is also a Gaussian pulse. So the answer is A. 49th question. The frequency spectrum of a Gaussian pulse is A, a signum function, B, a sinc function, C, a Gaussian function, D, a triangular function. We said the answer is C. Already we have seen this. So the frequency spectrum of a Gaussian pulse is also a Gaussian function. So the answer is C. 50th question. Which of the following is true? A, Fourier series is unique. B, Fourier transform is unique. C, both Fourier series and Fourier transform are unique. D, none of the above. The answer is B, that is the Fourier transform is unique. The Fourier transform is unique. So the answer is B. Let us see the 51st question. The spectrum width of a Gaussian pulse is measured approximately by 1 by tau, B 2 by tau, C 4 by tau, D 5 by tau. The answer is A, that is 1 by tau. The spectrum width of a Gaussian pulse is measured approximately by 1 by tau. So the answer is A. 52nd question. As compared to the Gaussian pulse, the rectangular pulse has more spectral content at frequencies A, above 1 by tau, B, below 1 by tau, C, above half tau, D, below half tau. The answer is A, that is above 1 by tau. So rectangular pulse will have more spectral components beyond 1 by tau. So the answer is A. 53rd question. The high frequency content of a rectangular pulse compared to the Gaussian pulse is due to A, the discontinuities, B, smaller width, C, small time period, D, none. The high frequency content of rectangular pulse compared to Gaussian pulse is due to its A, discontinuities, B, smaller width, C, small time period, and D, none. The answer is the presence of discontinuities in the rectangular pulse causes high frequency components of a frequency spectrum for a rectangular pulse. So the answer is A, discontinuities. The 54th question is as follows. The gate or rectangular function, rectangle t by t, means A, a rectangular pulse of unit amplitude and duration t, B, a rectangular pulse of unit amplitude and duration 2t, C, a rectangular pulse of unit amplitude and duration t by 2, or D, a rectangular pulse of t amplitude and duration 1. The answer is A. It is a rectangular pulse of unit amplitude and duration t. So the answer is A. So it will be a rectangular function which exists. This is the unit amplitude and it exists from t by 2. That means this will be minus t by 2 and this will be plus t by 2. Let us see question number 55. The Fourier transform of a periodic function f of t with a period t is given by A, 2 pi summation n is equal to minus infinity plus infinity fn delta of omega minus n omega naught, B, n is equal to minus infinity plus infinity summation fn of delta omega minus n omega naught, C, 2 pi summation n is equal to minus infinity plus infinity fn of delta of omega, D, summation n is equal to minus infinity plus infinity fn of delta of omega. The answer is A, that is 2 pi summation n is equal to minus infinity plus infinity fn of delta omega minus n omega naught. So the answer is A. Next question, 56th question. The Hilbert transform of function h of t is given by A, h cap of t is equal to 1 by 2 pi minus infinity plus infinity integral h of tau of d tau, B, h cap of t 1 by pi integral minus infinity plus infinity h of tau by t minus tau d tau, C, h cap of t 1 by 2 pi integral minus infinity plus infinity h of tau by tau d tau, and D, h cap of t is given by 1 by pi integral minus infinity plus infinity h of tau by t d tau. The answer is B. That is Hilbert transform h cap of t is equal to 1 by pi integral minus infinity plus infinity h of tau by t minus tau d tau. Answer is B. The 57th question is as follows. The inverse Hilbert transform of h cap t is given by A minus 1 by 2 pi integral minus infinity plus infinity h cap of tau by t minus tau d tau. B minus 1 by pi minus infinity plus infinity integral h cap of tau by t minus tau d tau. C minus 1 by 2 pi integral minus infinity plus infinity h cap of tau d tau. D minus 1 by pi integral minus infinity plus infinity h cap of tau by tau d tau. The answer is B. Let us see the 58th question. The Fourier transform of h cap of t is given by h cap of f is equal to minus j signum of f h of f, or h cap of f is equal to j signum of f, or h cap of f is equal to minus j h of f, or h cap of f is equal to minus j signum of f. The answer is of course A, that is h cap of f is equal to minus j signum of f h of f. Let us see the 59th question. A signal Hilbert transform are A orthogonal, B parallel, C same. The answer is A, that is orthogonal. Let us look at the 60th question. The Fourier transform of x of t is equal to 5 is A 10 pi delta of omega, B 5 pi of delta of omega, C 2 pi of delta of omega, D pi of delta omega. The answer is A, that is 10 pi delta of omega.